So let us see what is graph coloring. Firstly, there are two constraints in the graph coloring method. That is, we have to color the nodes or vertices of a graph such that it should take the minimum number of colors and no two adjacent vertices or nodes should have the same color. So we can see what is graph coloring. Graph coloring is an assignment of colors or any distinct marks to the vertices of a graph. Strictly speaking, a coloring is a proper coloring if no two adjacent vertices have the same color. So the constraints for the graph coloring method, first one is we have to use the minimum number of colors, and the second one is no two adjacent nodes or vertices should have the same color. See, origin of the problem. Next, why graph coloring? Many problems can be formulated as a graph coloring problem, including timetabling, channel assessment, etc. A lot of research has been done in this area. K coloring. A K coloring of a graph G is a mapping of V of G onto the integers 1 to K such that adjacent vertices map into the different integers. A K coloring partitions V of G into K disjoint subsets such that vertices from different subsets have the same colors. K chromatic graph. A graph whose chromatic number is K is called a K chromatic graph. A coloring of a graph G assigns colors to the vertices of G so that adjacent vertices are of different colors. See, here the chromatic number is 4 because we have taken the 4 colors to satisfy the constraints of the graph coloring method. First of all, here let us see if this is considered as the first node and it is colored with orange. Automatically next should not be orange, so they have taken red. After taking the red, if you follow this path, we can again color it as orange. Now coming to here, we should not take orange or red, so we have taken another color which is green. And now following this path, now we can take either orange or red. Now we have taken it as red. So here we have considered red. Next we can consider it orange, because if we have taken here orange and here red, then these two colors will be same. Which are adjacent colors should not be same. So here we have taken orange and here we have taken red. Again here we can take the red color. But coming to here, we cannot take orange or red or green. So we have taken different color violet. So the minimum number of colors that are required in this are 4, which are orange, red, green and violet. So the chromatic number of this graph is 4. So K chromatic graph. So here the value of K is 4 and we can say it as a 4 chromatic graph. And here backtracking takes place. The principle that is used in the graph coloring method is backtracking. That is, if we have seen any same color in this, we have to backtrack and check whether that another color can be there here or not. By that we can construct the graph by taking first node and write the possibilities here: orange, red, green and violet. Like that we can construct a tree and see what are the possibilities and the possible solutions for the given graph. See, for example, a state legislation has a number of committees that meet each week for 1 hour. How can we schedule the committee meetings time such that the least amount of time is used by such that two committees with overlapping membership do not meet at the same time? Let's just consider that as one example. Now see here, an vertex represents a meeting and H represents a conflict between two meetings. The chromatic number of this graph is 4. This 4 hours suffice to schedule committee meetings without conflict. So this is the real-time example of the graph coloring method, or we can say the application or principle is same between them. So without coming the conflict, we have to adjust the schedule we have to adjust the time or schedule the meetings. For that also we can use this principle. So just see here. Here it is the blue. First the color that we have taken is blue and such that followed by orange. And now here we cannot take blue or orange, so we have taken another color which is yellow. And here we can have the same color orange. And coming to this, again we can take here blue, here we can take blue, here we can take orange. Again here we cannot take blue, we cannot take orange, so we have taken this again yellow color. Again here we cannot take orange because here is orange, and as we have taken here blue, we cannot take blue also, and here there is yellow, so we cannot take yellow also. So we have taken another color which is green. So the total now the chromatic number is 4. There is no efficient algorithm available for coloring a graph with minimum number of colors. Graph coloring method is known as NP-complete problem. So this is about graph coloring method. Thank you.